Hello students, welcome to classroom. Today we will continue with what we have left in the previous lesson. So in the last class we were discussing about reflection and virtual images and real images. So we will move ahead with that, and then today we'll learn about some important terms associated with mirrors, and at the same time let us learn some more about the nature of concave and convex mirror. So let us start the class. So the first thing that we will do today will be to learn some more about the nature of the concave and convex mirror. So let's write it down. Nature of concave and convex mirrors. So we will be discussing about the nature of the concave and convex mirror. Now both of these mirrors belong to the spherical mirrors. So there are two types of spherical mirrors. We have the concave and the convex. If it is concave, then okay, yesterday in the previous class, in the previous session, we have discussed that we will be taking this, okay, this surface will be considered as the polished surface, the reflecting surface. So if this face is facing me, what type of mirror is this? Then this is a concave mirror, okay. And then if this side is facing me, if this side is facing my face, then this will be considered as a convex mirror, okay. So you can use your hand to get an idea of what or how concave mirror will look like and how convex mirror will look like. All right, so let us continue. So nature of concave and convex mirror. So let us study them side by side. We will have to draw a ray diagram. We'll have to draw both the mirrors. So let us draw a concave mirror here. So let's draw a concave mirror here, and side by side let us draw a convex mirror here, okay. So this side, okay, this side, left side and the right side. The left side is the polished reflecting surface, okay. That makes the right side the back side. So let us show the back side by drawing like this, okay. It is very important to highlight the back side. So this is how you highlight the back side. The same thing we'll do for the convex also. So this side is the left side, okay, your left hand, so left side, your right hand, so right side, okay. Now this side, the left side, is the polished, is the reflecting surface. So the right side will be the back side. So let us indicate the back side, the non-reflecting side, by drawing this, okay. So we are done. Now what are we going to do now? Yes, let us draw a line which is called the principal axis. So this line is called the principal axis, okay class. So draw a line which is called the principal axis, okay. Now this line is called the principal axis. Don't worry, we will be discussing about this very soon. In today's class itself we'll be discussing, so we will explain, I will explain in detail. Now yes, let us draw light rays now, okay. So let's say a ray of light is traveling towards the mirror, okay. This is a ray of light, ray number 1, okay. So it's traveling towards the mirror. Then let's take another ray, okay. We can take many rays, but 2 rays will be enough. So let's take another ray traveling towards the mirror. So this ray is traveling towards the mirror. This is ray number 2. All right. Now what happens now? The ray has touched the mirror at this point, okay. This is the point of incidence for this mirror, okay. Now what will happen? From this point reflection will take place, okay. So how will it reflect? This is a concave mirror, so it will reflect back like this. All right, this is the reflected ray. I will show by drawing the arrow. So the arrow, okay, this is a reflected ray. This is the incident ray. The ray which is yet to touch the mirror is called the incident ray. This is coming from an object and it's heading straight towards the mirror. It has made contact with the mirror at this point. After making contact, it will reflect back, because this is a mirror. Okay, mirrors reflect back line. So this, after from this point, it will reflect back, so it's reflecting back. Okay, and it's going, okay, wherever it wants to go, it will go all the way down. Now let's consider the second ray. So the ray goes, okay, straight towards the mirror, hits the mirror at this point, so this becomes the point of incidence. Okay, then reflection will take place from here, so it will reflect back. Now as it reflects, it will go like this. Okay, so this is the reflected ray. It is very important to indicate the arrow. You may lose some mark if you don't indicate the arrow. You will actually lose mark if you don't indicate the arrow, because arrows are very important. Okay, you have to know how to indicate the right arrows also. So arrows are needed to indicate the direction of the ray. Okay, so remember, you have to draw the arrows also. All right, so this arrow is indicating the path which the reflected ray will take. Okay, now do you see this point? The two reflected rays, they meet at this point, is it not? This point is very important. Okay, class, this point is called the focus. Okay, this point is called the focus. Okay, so we took two rays. Okay, you can take any amount of rays, you can take another ray. Okay, but still then it will happen like this. So the ray goes like this after reflection. Okay, it will pass through this point, then we can take another ray here. Okay, it goes, hits the mirror. After reflection, it will pass through this point like this. This is the reflected ray, this is the ray heading towards the mirror. So we notice that all of the reflected rays, they meet at this point. Okay, they converge at this point, they converge, they get together, they come together at this point. So this happens in concave mirror, and this, because of this, concave mirrors are also known as converging mirror. So the nature of the concave mirror is, what is the nature of the concave mirror? The nature is converging. Okay class, converging, remember this. The nature of the concave mirror is converging. Converging means they meet at one point, they converge. Okay, previously they were all traveling separately. Four rays were traveling separately. After reflection, they all converge at this point. This is the reason why concave mirrors are known as converging. Are we clear with this? Okay, then we go to the next one, which is the convex mirror. So here, let us draw the rays again. So like in the previous case, let me draw one ray here. Okay, this is the ray coming from the source, so it's heading towards the mirror. Okay, ray number 1. All right, then again down, we will draw one more heading towards the mirror. Okay, this is the ray number 2. All right, so ray number 2. Now how will this be? Okay, how am I going to draw? Now this is a convex mirror. Okay, this is a convex mirror. So how will the ray, or what path will the ray take after reflection? So the ray travels all the way, touches the mirror here, so this becomes the point of incidence. Okay, now reflection will take place here. How will it reflect? It will reflect. Okay, it will reflect. Now for convex mirror, we have to continue this. Okay, we have to draw and continue this, we have to extend this also. So the ray, this is the point of incidence. All right, now reflection will take place from this very point. Now it will reflect like this. Okay, it will reflect like this. Reflection will take place like this. Now if we backtrace this, we have to backtrace for convex. Okay, we have to backtrace. So this point, this becomes the focus. Okay, now for ray number 2 also, reflection will take place. So this is the point of incidence, so reflection will take place, so it will reflect. But remember that, okay, on backtracing, it should come to the focus. So make sure that your diagrams are correct. Okay, like this. This is the reflected ray. Okay, so look at the two reflected rays. Okay, they are, this ray number 1 is reflecting and it's going towards this side. Okay, ray number 2 is reflecting and it's going toward this side. Okay, now if we backtrace this again, we will find that they appear to meet at focus. All right, they do appear to meet at focus. Okay, see here, after reflection, the rays here, they actually do meet A-C-T-U-A-L-L-Y. They actually do meet. Okay, so this will give you a real image. Okay, real image, is it not? Yesterday, I think in the previous video, in the last video, we have discussed about real images and virtual images. This gives you a real image because after reflection, the rays actually do meet. Okay, here this will give you a virtual image. Why? Because after reflection, the rays, they don't actually meet, isn't it? They don't actually meet. We have to do back tracing. Okay, we have to do back tracing. So they appear to meet. They appear to meet, but then in reality they do not meet. Okay, now what is the nature of the convex mirror? Now time to write the nature. Okay, time to write the nature. We may draw 2-3 more, but still then, okay, it will be the same. No matter how much you draw, it will still be the same. If I draw one more here, okay, the same thing, it will reflect from here. But then remember that we will be backtracing it, so basically it should appear like it's coming from here, so it's gonna be something like this. Yes or no? Okay, then let me draw one more here. All right, then this is the point of incidence. So again, remember that, oh sorry, so you need practice. Okay, students, even we teachers will make mistakes, so you have to practice. You also have to practice a lot. Okay, ray diagrams, you need a lot of practice. Okay, so that you get a good balance of it. Okay, and then with practice, I guarantee you, okay, your drawings will be very, very good. So a lot of practice is required. So see, they all appear to meet at focus. All right. Now nature, concave mirror nature was converging. What about the nature of the convex mirror? Anybody? The nature of the convex mirror will be, yes, yes, correct, diverging. Okay, it will be diverging. So diverging. So the nature of the convex mirror is diverging. Are we clear, class? Okay, so let's continue to the next topic. The next topic is very, very, very important. Okay, so please make sure that you draw this. Okay, take out your notebook, and I keep on telling you again and again, students, to maintain notes. Okay, maintain notes because you are going to study from the notes. So in every class, I will try to remind you to take down notes. Okay, so do not be lazy. Laziness does not benefit anybody. Okay, we should be working hard. Okay, do not ever be lazy. Now we move on to a very, very important topic now. Some important terms associated with spherical mirrors. Okay, so let's write okay, let's write like this. Some important terms associated with mirrors. Well, I do not have the best handwriting in the world, so please do excuse me for my bad handwriting, but all I want you all is to learn, so please don't mind the bad handwriting. Okay, now so this is very, very important, and I want you all to understand this thoroughly. All right, so there are some important terms associated with mirror, so let us start them one by one. So the first thing that we will do will be, we'll draw ourselves a concave mirror. Okay, so let's draw ourselves a concave mirror. I'll draw in the side somewhere here. All right, let's say like that. So this is a concave mirror. So which side is the reflecting side, class? The left side or the right side? Which side is the reflecting side? Concave mirror like this. So this is not the one facing me, left side. Okay, so this side is the reflecting side. So reflecting side is here, that side is the non-reflecting side, the back side, which I will show like this. Okay, so that there is no confusion for me. Okay, now let's give name to this one, A and B. Okay, I have to draw a little bigger because I have noticed that if I write very small, you don't see, isn't it? So I have to write a little bigger. Okay. Now, the first thing that the first term that we will be learning together will be number one, aperture. Okay, APERTURE, aperture. Now, what is aperture? What is aperture? I will tell you what is aperture. Now, now I want you all to pay attention to my hand. So this is my hand. Okay, my hand. Now, if I keep like this, then I'm providing a lot of surface area. Okay, a lot of surface area, allowing more light to hit my hand. Okay, to land on my hand and then reflect back. Okay, so in this position, a lot of light gets to reflect from my hand. Thereby, my hand is visibly clear to you. But what if I curl my hands like this? If I curl my hands like this, then on curling my hand like this, what has happened? See, the surface area available for light to reflect has decreased a lot. Yes or no? Is it not? It has decreased a lot, see? Okay, so compared to this and compare with this. So position 1 and position 2. So which position has got more surface area available for light to reflect? It's position 1. Okay, so this is what aperture actually is. Okay, aperture is actually the part of the spherical mirror from which reflection actually takes place. So the part of the spherical mirror from which reflection actually take place. Okay, so see, reflection will take place on these surfaces, is it not? Okay, on this surface, if I keep my hands like this, from here, from the top to this part, every part of my hand, reflection will take place because light, okay, light hits these spots, so reflection can take place. Okay, but if I curl it like this, then what is happening is that, okay, some of the surface areas are hidden. Okay, now, so reflection of light will take place from a very small area. So aperture is the part of the spherical mirror from which reflection actually takes place. So in simple, okay, aperture is nothing but the surface area available for reflection of light to take place. So let's write that. Okay, so what is aperture? Aperture is the surface area available please write down the notes, okay, students. The surface area available for reflection to take place. All right, so surface area available for reflection to take place is called aperture. Okay, next point, after discussing aperture, now see, we know that mirrors are cut from spherical spheres, isn't it? We know that mirrors are cut from spherical sphere. So this is a part of a very big spherical sphere. Okay, so just to show you how big it is, so it can be somewhat like this. Yes or no? It can be somewhat like this. Okay, so this aperture is part of a big hollow sphere. Okay, since it is a sphere, it will have a center. So it will have a center. Okay, it will have a center. So this center of the big sphere is called center of curvature. So the next point is center of curvature. CENTRE, center of curvature. Okay, center of curvature. How will the definition be like? So center of curvature is the center of the spherical mirror. Very simple. Just write down center of the spherical mirror, and it is represented, it can be represented, or it is represented by capital letter C. Okay, capital letter C. All right, Now, after this, the third term that we will study will be the principal axis. So now the third point is the principal axis. So what is this principal axis? So the principal axis is a line which passes through the center of curvature and it touches the mirror. Alright, so the principal axis is a line which passes through the it passes through the center of curvature and it touches the aperture or it touches the mirror. Okay, remember this. So this is the principal axis. This line is called the principal axis. Okay, let's write the definition. A line which passes through, I'll just write C, okay, C for center of curvature, through C, okay, through center of curvature, okay, let's just write everything, center of curvature, through center of curvature and touches the mirror. Okay, this is called the principal axis. It is a line which passes through the center of curvature and it touches the mirror, or you can also say it touches the aperture. After all, the aperture is from here to here, isn't it? Okay, now next one, the next one is a very important point called the pole. Now time to tell you what is the pole here. So what is the pole, or what is the pole? Students, this is the pole represented by capital P. This is the pole. Okay, this is the pole. So the pole is a point on the aperture, or you can also say the pole is a point on the mirror, okay, where the principal axis touches the mirror. So this point, we're talking about this point, okay, this point is called the pole. And how do you define the pole? Okay, pole is where the principal axis strikes the mirror. That is also a good definition. Okay, pole, this pole is where the principal axis strikes the mirror, means it touches the mirror. We can also write like that. So what is pole? Pole is where the principal axis strikes the mirror. Okay, if you find this definition a little difficult, then see here, you can also write like this. The pole is a point on the mirror. Okay, very important. That also is good enough. The pole is a point on the mirror, okay, whereby the principal axis, okay, whereby the principal axis touches the point. Okay, you can also write like this, or you can just stick to this definition that the pole is where the principal axis strikes the mirror. That means the pole is where the principal axis, this line, makes contact with the mirror. Okay, simple enough and it's correct. Okay, so the next one, point number 5. So what will be point number 5? Point number 5 will be radius of curvature. Radius of curvature. Okay, the pole is represented by capital P. Okay, so remember that the pole is represented by capital P, just like center of curvature is represented by capital C. All right, now we are discussing about the radius of curvature. Sometimes I'm writing capital, sometimes I'm writing small, so I wrote this in small letter. Okay, please do forgive me. So radius of curvature. So the radius of curvature. What is the radius of curvature? Let's go and have a look at this figure. Where is the radius of curvature? Now before we go and I tell you what is it, I want you to be all familiar with the word radius. Are you all familiar with the word radius? Yes, of course, isn't it? Radius is a very common word which we have heard since lower grades. Okay, now radius of curvature. Where do we find this word radius being used a lot? In circles. Okay, so we are all familiar with circles. This is a circle. Then every circle has got a center. Okay, and from the center till the circumference, if we draw a line, what is the name of this line? Yes, very true. This is called the radius. Okay, so radius of curvature. We have a circle, we have a circle. We have a center, we have a center. And from this center, a line is drawn. A line is drawn. Okay, touching the mirror. So this line is called the radius of curvature. Okay, so what is radius of curvature? The distance between C and P. All right, class, the distance between C and P. The distance between C and P, that means we're talking about this line between C and P. The distance between point C and point B. This is called, between P and C you have this line. This line is called the radius of curvature. Okay, so radius of curvature, the distance between C and P. All right, the distance between C and P is called radius of curvature. Now last point, the last point. So before I go to the last point, I will show you the representation also. So the last, okay, so it is represented by the letter capital R. Okay, now very soon there is a formula, okay, for R with respect to focus. We'll also discuss that. Now let's go and find the last point, which is called the focus. All right, so what is focus? Okay, focus on your work, focus on your studies. Is it the same focus? Of course not. This focus is totally different from that. So what is focus? See, focus is the point where all the reflected rays meet, which earlier, before we started discussing this, I have shown you in terms of concave mirror, even in the convex mirror also. So in terms of concave mirror, we found that all the rays after striking the mirror, they converge. Where did they converge? At what point did they converge? Did they not converge at focus? So they all converge at focus. So focus is a point where all the reflected rays, they meet. All right, so focus is a point where all the reflected rays meet. That is also what you have to write. So I'll show you where the focus is. The focus is here. Okay, first of all, let us write the definition of focus. So focus is a point. Focus, a point where all the reflected rays meet. But we have seen that in terms of convex mirror, they do not meet. They appear to meet. So we have to even address that. So a point where all the reflected rays meet or appear to meet. All right, so now we have addressed both you have written the focus with respect to both concave mirror as well as convex mirror. All right, now let me show you where the focus is. Now see how I will identify the focus. Now where will the focus be? Remember that the focus will be between C and P, but the question is, where will it be? Will it be here, or here, or here? Okay, so where will it be? Will it be here? Will it be here? Or will it be here? Will it be in position 1, position 2, or position 3? Where will the focus be? Now, the answer is our focus will be at position 2. Okay, not at 1, not at 2, not at 3, sorry. It will be at position 2. Now, on what criteria am I saying that the focus will be at 2? Why can't it be at 1? Why can't it be at 3? See, there's another way of identifying the focus, and you have to remember this, that focus is also the midpoint between C and P. Alright, I repeat again, focus is also the midpoint between C and P. That means you see this line, CP, you see this line CP. Suppose CP is say 20 centimeter. That means from this point to this point, let's say it is 20 centimeter. Then midpoint of 20 centimeter will be, what will be the half of 20? 10, isn't it? So where will you mark 10? You will be marking 10 somewhere here, isn't it? Okay, so this will become the focus. So our focus is here. This is our focus. Okay, because focus will be the midpoint of this line from C to P. So this line from here to here, if you look carefully, the middle will be somewhere here. So our focus has to be here. So this is another way of finding the focus. This is actually helpful for solving numericals. Okay, so this is the definition of focus, but this is for writing the definition. But for solving numericals, which we will be doing very soon, this knowledge is very important. Knowing that focus is half of radius of curvature. Okay, and that is the formula which I was saying earlier, that we have a formula between radius of curvature and focus. Which formula is that? The formula is this. See, here you have understood that focus is half of radius of curvature, isn't it? So focus is half of radius of curvature. You want focus? Divide the value of r by 2. If r is 20, then focus will be at 10. Yes or no? Okay, focus will be 10. Now from this we can find the formula for radius of curvature also. So we do cross multiplication. So it will be f into 2, and then we have got r. So basically this is r is equal to 2f. So you want to know radius of curvature? Just multiply the value of focus twice. If focus is 10, then how much will be radius of curvature? It will be 2 times of 10. 2 tens are 20. So radius of curvature will be 20. Alright, so this is a very important formula. The knowledge of r and f, the relationship between r and f, is very helpful in solving the numericals. So we will end the class from here today. So basically, before we leave, what have we learned today? Today we have learned about the nature of concave and convex mirror. Okay, remember that the nature of concave mirror is converging and the nature of convex mirror is diverging. Okay, then we have studied some very important terms which are associated with mirrors and which you all should know. So we have the aperture, we have the center of curvature, we have the principal axis, we have the pole, we have the radius of curvature, and finally we have the focus. This knowledge should be thorough. You should all be very thorough with this knowledge. Okay, with this, if you are very thorough with this knowledge, the lesson becomes very easy. So I thank you all for joining, and I'll see you again in the next video. God bless you all.